Okay, so time for final exam review F. So here we go. Pull down. We're doing problem, well, let me give the title as usual. So we're talking exam, actually final exam, final and review, and it is F, I believe. Okay, we're doing problem number 31. Here's how it might be presented to you. 13x squared, x squared minus 19 plus 10x plus 12x4 divided by minus 3x squared. And this is a little bit on the hard side, this one that they gave us. Okay, that's what it looks like. Now, what video is this linked to? For you to see our example that we did in class, go to video 69. Okay, anyway, what this one I want to do together with you. Okay, now we said that we got to arrange this in with the highest going first. Right, we're doing long division here. We can't do synthetic division because it's not just a plain x, it's an x squared. Plus it's not a plain 1x, there's a negative 3 here. So forget synthetic division, we got to use long division. All right, so how does long division work? Put the highest one first, 12x4, followed by, there's no x cubed, so you got to represent it, 0x cubed. Followed by 13x squared is represented. Followed by x, there's 10x, so that's represented. And then there's the constant, minus 19, the regular number. And we take that whole thing and we divide it by, let me cordon off this. This is our work. And we divide it by minus 3x squared. You see the minus 3x squared on the right-hand side. Plus 0x, that's got to be in there. 0x has got to be represented in the divisor. And plus the number 2, and then we're done. Okay. Now, like we did, I think, on the video, I'm quite sure, on the right-hand side, we did our scrap paper. And our first move is to take 12x4 divided by minus 3x squared. 12x4 divided by minus 3x squared. These cancel out to become negative 4. x4 over x2 is x2. 4 minus 2 is 2. And where do I put that? I put it right over here above the 13x squared, minus 4x squared. What do I do with that minus 4x squared? Minus 4x squared times negative 3x squared is 12x4. That's 12x to the 4. That's what we wanted. Minus 4 times a 0 is going to be just plain 0x cubed. So I'll write the whole thing out, 0x cubed. Minus 4x squared times 2 is going to be minus 8x squared. There we go. Subtract this whole thing from the second line from the first line. This is gone. This is zeros, it doesn't mean anything. And 13 minus 8 turns into 21x squared. Bring down the 10x. Bring down the 10x. Now the truth is, you might as well bring down, the minus 19 as well, right? Because we anyway have a trinomial over here that's going to go. All right. So now, what's the next thing to do on scrap paper? The next thing to do on scrap paper is to take 21x squared. 21x squared divided by this old negative 3x squared, right? So, minus 3x squared. Where does that get? The 2x squareds cancel out, and I get a negative 7. Put the negative 7 above the negative 19. Doesn't really matter because we're pretty much out of, there's nothing else to do. Negative 7 times negative 3x squared is 21x squared. Negative 7 times 0 is going to be 0x. I'll write it all down, 0x. And negative 7 times 2 is negative 14. Subtract this second line from the first line, that's gone. 10 minus 0 is going to be 10x. And minus 19, minus, that's plus 14, is going to be minus 5. And there's our full answer. The answer to give to Alex is minus 4. Here's the quotient. Here's the quotient. Minus 4x squared minus 7. I don't need them separated by a space anymore. And here comes the remainder, 10x minus 5. 10x minus 5 over minus 3x squared plus 2. The old minus 3x squared plus 2. I could get it right from there. Minus 3x squared plus 2. This is the answer, and the problem is done. Let me move up the paper. Here we go. We have some more paper. And let's go to problem number 32. Okay, here's 32. It's x plus 2 over 3x minus 6, and this is a real old one, 3x minus 6, divided by, divided by x squared plus x minus 2 divided by x squared plus x minus 6. Let me give you some hints of what to do. You factor all of them. Anything that can factor, that won't factor, but the other three can factor. And then you cross out all. First you flip and multiply. Flip the second one and multiply. Factor everything, and then cross out everything you can until you simplify it as much as you can, and then the problem will be over. In any case, where you can look up a problem almost exactly like this. In exam 1, review A, problem number 3. There we go. Let's get a new piece of paper here. A new piece of paper. Okay. Let me carefully go down here and get my new piece of paper. Okay. So that was problem number 32. Here comes problem number 33, which I also want to do together with you. All right, bring this down. Fine. Oh boy. I didn't want that, but too bad. Okay. So here's what 33 says. Use the factor theorem. So it's going to have some fancy words in here to determine whether. So I want to show you how Alex, what it looks like in Alex, pretty much, roughly speaking, but pretty much I'll have the elements that are needed there. Whether x minus 3 is a factor of the polynomial p of x equals x cubed minus 3x squared minus 4. Okay, now then Alex adds something like this. Specifically, here we go. Evaluate. And as they sort of tell you how they want you to do this, you could really do it different ways. Anyway, evaluate p at the proper value. And then actually I don't need that comma, and then determine whether x minus 3 is a factor of the polynomial. X minus 3 is a factor of the polynomial. of P of x. Okay, that's how I'll call it. Fine. So what does Alex do? Besides all of that, what else does Alex do? Alex puts a P waiting for some number that you're supposed to put in there equals a number. It shows you what it wants you to do. And then on the side, it puts two boxes, x minus 3 is a factor. And the other box would you choose if x minus 3 is not a factor. Is not a factor. Okay, so here's what you do. What you do is what we need to do is, this is how the answer works. We need to take P of 3. Where am I getting 3 from? Not minus 3, 3. What's the P of 3 mean? Insert 3 into the function that they gave us, into the polynomial that they gave us. Every time you see x, replace it with 3. Okay, that would mean it's 3 to the third minus 3 times 3 squared minus 4. This is an important problem. It's not so bad, and you haven't seen it before, so we need to look at it here. Minus 4. All right, so what happens? What's 3? Let me bring up the paper to make sure that it can be seen. I sometimes forget to do that, but this turns into 27. 3 squared is 9, and minus 3 times 9 is minus 27. Minus 4 equals minus 4. So you would put a 3 in this box, and you put a minus 4 in that box. Now, is x minus 3 a factor or not? Well, this would have to become 0 for x minus 3 to be a factor. Since it's not 0, so you pick x minus 3 is not a factor. And that finishes off problem, I think this is 33. Here comes 34. Let me bring up the paper and more. There we go. 34. Okay. So this one I also need to show you, and unfortunately it involves some graphs, which I'm not good at, but let's try. So over here, it's asking you about symmetry, right? So it's going to either be symmetry around the origin. I'm sorry, around the first one they'll put probably is x-axis, then they'll put a box for y-axis. They'll put it vertically. I'm running out of room, so I'm putting it horizontally. We've seen this stuff before. Origin or none. Okay, fine. So now, what if it looks like this? We've seen those boxes before, at least. It goes like this, then like that, then like that, then like that. Right? Let me not have that there. Okay, so what is this? The symmetry? What is this? Has this have any symmetry? Is it none? No. The answer is that this one is the origin. It's symmetrical around. You pick the box that says origin. There it is. There's the origin. It's like a mirror image around the origin. That is 34A. 34B. What about this picture? It's a circle, but it's not a circle over here. It's a circle with its center at the origin. Oh, if its center is at the origin, then it actually is symmetrical about all of them. You would pick the box for the x-axis. You would pick the box for the y-axis. And you would pick the box for the origin for a circle that's symmetrical around the center. If it was only symmetrical in some other, not around the origin, then you would pick the, you wouldn't have that situation. Okay, so now there's one more, there's C, which looks like this. And it's a parabola sort of, but it's going like that and like that. It's not symmetrical around the origin. There's nothing on the other side of the origin. But what's this axis? This is the x-axis. So this is actually symmetrical about the x-axis.